So in this video, you're going to be learning about how to find out the number of atoms in individual molecules of a compound. So we're going to start out by reading the subscript. A subscript is the small little number found behind the atom. It tells you how many of that atom are there. So in this case, we have two subscripts behind the hydrogen, giving us a total of 2 hydrogens. Now, if nothing's written behind the atom, it's an understood subscript of 1. So we have 1 oxygen. So based on the subscripts, we have 2 hydrogen, 1 oxygen found in a water molecule. Now, a molecule of hydrogen peroxide, we have 2 hydrogens again. So 2 hydrogens. There's a subscript of 2 now behind the O. So we have 2 oxygens. Finally, a little bit more complicated compound. We have an understood subscript of 1 behind the nitrogen, meaning we have 1 nitrogen so far. A subscript of 4 behind the hydrogen, so we have 4 hydrogens. And we have another understood subscript of 1 behind the N. So now we have another nitrogen. We'll add that to our first nitrogen, giving us a total of 2 nitrogens. And finally, we have a subscript of 3 behind the oxygen. So we have a total of 3 oxygens in this molecule. 2 nitrogen, 4 hydrogen, and 3 oxygen. So now we're going to be making things a bit more difficult by adding what's called a coefficient to the molecule. The coefficient is a number found in front of the molecule that gets multiplied across the entire molecule. So every atom gets multiplied by that number in front. So we started out with our hydrogen, which once again is a subscript of 2, but now that gets multiplied by the 4, and that's going to give us a total of 8 hydrogens. And once again up here we have our understood subscript of 1 behind the oxygen. Multiply that by 4, gives us 4 oxygens. So in this next problem we have a coefficient of 5 in front of the molecule. So we see our subscript of 2 behind the H. We multiply that by the 5 to give us 10 hydrogens total. The 5 also affects the oxygen, so we do 5 times the subscript of 2. Multiply those together to get a total of also 10 oxygens. So we have 10 hydrogens and 10 oxygens total in this molecule. In our last molecule, we have a coefficient of 3. We start with our understood subscript of 1 behind the N, giving us a total of 3 nitrogens. Behind the hydrogen, we have a subscript of 4. We'll multiply that by the 3 in front to give us a total of 12 hydrogens. The carbon also has an understood subscript of 1. Multiply that by 3 to give us 3 carbons. And last, we have oxygen with the subscript of 3. Multiply that by the 3 in front to give us a total of 9 oxygens. So now we have 3 nitrogens, 12 hydrogens, 3 carbons, and 9 oxygens. So then the next twist we'll be adding to this is including polyatomic ions, or in simple terms, just adding a parentheses. So this parentheses in a molecule means that the subscript behind the parentheses gets carried through to all the atoms within that parentheses. So that 3 gets multiplied to the H and the O. So let's start with our aluminum, which is a subscript of 2. It's outside the parentheses, so it has only 2 aluminums. Now this 3 gets carried through the parentheses to the oxygen. So there are 3 oxygens. And the 3 also affects the hydrogen. So there are 3 hydrogens as well. In this next molecule, we have nitrogen, which has the understood subscript of 1. So we have 1 nitrogen. We have a subscript of 4 behind the hydrogen for a total of 4 hydrogens. Notice that it's outside the parentheses, so it's not affected by that 3. But the N and O are both affected by this 3 since they're inside the parentheses. And we have 3 nitrogens. Add that to our 1 nitrogen from before for a total of 4 nitrogens. And we also have 3 oxygens. So we have 4 nitrogens, 4 hydrogens, and 3 oxygens. Remember, outside the parentheses, not affected by the subscript. So in our last section, we're going to take the coefficients, we're going to take the polyatomic ions of the parentheses, we're going to combine it all together to give us our most challenging molecules to solve the atomic composition of. So let's start by taking the 2 and behind the beryllium, multiplying it by the coefficient of 4, giving us 8 beryllium. Now this 2 carries through to the boron inside the parentheses with the understood subscript of 1. We have to take that boron though, multiply it by the coefficient in front. So it's 2 times 4 gives us 8 borons. The 2 gets carried over to the hydrogen, 2 times 4. But we also have to multiply it by the coefficient in front. So it should be 8 times 4, 32 hydrogens. Finally, we have a coefficient of 2 in this last molecule. Carbon has a subscript of 6. Multiply that by the 2 for a total of 12 carbons. Now inside the parentheses we have 12 hydrogens and a 2 outside, so 2 times 12 is 24. Multiplied by the 2 in front for a total of 48 hydrogens. Finally, we have chromium. Gets multiplied by the 2 outside the parentheses, and then by the 2 in front for a total of 4 chromium. We have, in the end, 12 carbon, 48 hydrogen, and 4 chromium.